So the next part of this session is on soil compaction and productivity. Our first speaker is Dr. John Bennett from the University of Southern Queensland, the National Centre of Engineering and Agriculture, Senior Research Fellow, Soils. His topic is on feedback on the new John Deere picker, impacts from farm through to industry. Please welcome John.
So all those people leaving, I'm assuming they're the ones that think soil compaction is not a problem. Right. So what I'm giving here is only a portion of what this project's about, but it'll give some insights, and there's a lot more to come. The project itself is CRDC funded, but it's more than just soil compaction. It's moving towards having some sort of assessment framework, and not necessarily a paper-based tick and flick type program or framework, but something that's a little bit more along the lines of what Brett was talking about. There's some other staff that are there, and I need to mention that Troy Jensen and Dio Antil have contributed this very much, and also a collaborator from overseas, Thomas Keller. He is the author of SoilFlex, which means nothing to you now, but will be something that could be quite useful in determining when to go into a field or how much of an impact you might have when you do. Excuse me. So as you can see, there's a number of people that have been involved at a grower level in having us come onto their farms and do a few things. These are the primary experiments, I guess. We measured impact, which is not very interesting in my mind, because if you take the big heavy thing and you put it onto your paddock and it causes compaction, well, now you've got compaction, and that doesn't just simply go away. But it is useful to know what the impact is. So in all of the farms that we've been, we've measured impact, of course. For me, the more interesting things are what is the effect on cultivation? How does that compaction in our soils, our cotton soils, which you know all shrink and swell, what's the regeneration of those soils naturally? So we know from previous work by Des McGarry that there is some level of regeneration. It's not massive, but what does this new, bigger, heavier machine mean in terms of that soil regeneration? So we've got that there. I don't have any data for that for you today, if you're really keen to see that, sorry. Controlled traffic, we've been looking at this at Oscott, and also Jamie Grant, who is a dryland farmer, but I'll go through a little trial there in a minute, but has not been on his soil for 15 years, except for on his wheel tracks. So that gave us a tremendous capability to actually look at impact, of course, and then to use that to validate some predictive capabilities. The last one there is an experiment being done by a student of mine, Sterling Robertson, defoliation moisture management trial. We saw at Glenn Smith's place that he had a paddock that was absolutely bloody sopping wet, and he was in there and he gave me a call and said, "You'll be really pleased. There's some great ruts, and you'll see some really interesting stuff in terms of soil compaction, but not in this field. The one you're on is next door to this field." So by the time we got out there, he hadn't been able to defoliate that, and by the time we got there, the plants defoliated, ready for harvest, and there was hardly a mark on the soil. So that got us thinking, can we manage moisture through something we all understand, which is moisture drawdown? So that's where we are, but here's what we're going to talk about today. Soil impact of, as I said, we've measured it, and we're going to talk about that first up, but then look at the energy implications. And then what I think is probably the most important is to discuss, well, what are the pros and cons of the CTF versus a standard configuration, so controlled traffic farming, of course. Then I provide an option. It's not necessarily the option, but it's an option that I think is probably pretty useful, and finish with a bit from where we might head in the future. So the work we did at Jamie Grant's, if you can see this picture here, there's little plots which have plastic over them. And in between there's another row of plots, but you can't see them because I didn't bother putting plastic over those. This one here was wet to field capacity or near field capacity in the top 40 centimetres. Now these soils are always in a state of wetting or drying, but as close as we could, it was wet in the top 40 centimetres. Field capacity in these ones was with enough water was supplied to get the soil wet to field capacity down to a metre. So that gave us some very wet points. And this one through the middle here is just under the natural conditions. Now, unfortunately, there were a few rather large rainfall events, so it's not as dry as we wanted it to be, but it gives us 3 moisture contents over which to, or 3 moisture profiles, I should say, over which to compare. Why is this important? Because it's not just the moisture at the surface that is important, but also the moisture that's below the soil. So the profile of moisture, which is not uniform generally speaking, means that we're going to have a compaction impact potentially that we either can't see, or the soil may be so wet that we're not having a compaction effect below, but we're seeing some massive rutting on top. And that's an important point. There's a difference between rut development and soil compaction. Just going to switch to the video. So before we actually traversed any of it, we took some soil samples so we knew what the bulk density or the soil compaction level was prior. That's just some images of us bagging that sort of stuff up. There are our moisture plots. They're uncovered, and we sent a standard JD 7760 over at the recommended tyre pressure, and that's what you're seeing there now. And that's running over the wet only, the field capacity at 0 to 40 centimetres. You saw the soil visibly move there. That's pretty important. The other tracks you can see there, except for the donuts, are Jamie's controlled traffic. The donuts are us imposing on his farm and him trying to spray around us. So that's the CTF going over there. Noticeably, you can see that the ruts are deeper, but of course there's only the 2 of them. And that there is a sheep's foot roller. Jamie had one and let us drive into his paddock with it. And I'll tell you why that's an important thing in a minute. But what we saw here is that where it was wet, we got very massive rut development. And whether it was wet at 0 to 40 at field capacity or down to a metre, the rut development was similar. So straight away we know that those 2 moisture profiles were behaving similarly. That's not a surprise to us. The soil there is moist at the surface, and the rut development is due to the soil being moist at the surface. So soil can behave like a liquid, and when it starts to, you didn't see it there very well, but that heave, that movement is where it's starting to move towards that point. And that's in between it being plastic and being a liquid. Now, a very quick lesson in soil science, sorry. The point I'm making here is that soil moisture is the main concern. It doesn't matter where you are in the Australian industry, we're pretty much stuck with the same thing, and that is we have high clay content soils. So soil structure structural strength is governed by how dry the soil is, yes, but also a thing called the internal angle of friction. But that really only applies to sand, so we don't have high sand content. And to give you just a quick explanation of that, the difference between the internal angle of friction and then cohesion, which is a clay concept, if you take your hands and you form fists and place the knuckles together, consider them being sand grains and try and force them over one another. You can do it and it kind of hurts. If you wet your hands now and do the same thing, it's a little easier, but not much more easier. Now if you consider your fingerprints to be the clay particles, for example, and you try and force them over one another, it's not all that hard compared to forcing your knuckles. If you wet your hands and do the same thing, it's now considerably easier to move your hands. It's exactly the same thing that's happening in the soil. Clay particles are teeny tiny. So with small increases in soil moisture, you get a large decrease in soil strength. So that means it's able to slide over one another as the machine goes over. So it doesn't matter which part of the industry you're sitting in, you'll all suffer from a high clay content. That's fantastic for holding water in the ground. It also means that managing soil compaction is very important, and that soil moisture becomes the most important aspect of that. So that raises a question, well, how moist and when should I be concerned? Those ruts that you saw forming, a lot of people tell me, well, it's all right. When I drove on my soil, I don't see a rut forming. And the point of that video, because I haven't got all the results from that at the moment, was simply to say that you saw the ruts forming where it was wet, but you didn't see them forming in between the two wet sites. However, there was a very significant increase in soil compaction at the wet sites at the surface as compared to the wet sites at the surface. So the dry sites were actually compacted, but the wet ones were not, and that's because the water that's in the soil is stopping the soil pores from closing, i.e. it's acting like a hydraulic fluid, and the soil is forced out. So that was that heave, you were seeing it moving up. That wasn't occurring in between, but in between those two sites were still relatively wet. Now, I don't have the data for that, but what I do have is the data from 3 farms that I have been working on. What you're seeing here is Nigel Corish, Glenn Smith and Oscott's data, and this is a proctor test. What we do is we take the soil, same soil sample, and we prepare it at different moisture contents. Then we apply a given force, so the same force, and we then measure a change in volume and then the weight that's within that volume. That gives us the density, and that's what we've plotted on the curve here. The highest point there is what we call the maximum dry density. So if we make the soil wetter, we'd consider compaction to be less of a risk. If we make the soil drier, we consider it to be less of a risk. I'm not suggesting we traverse wet. That's not a good idea, because then you've got the issue of ruts and smearing and blocking pores in that respect. But if we just think of this from compaction, there's this point here. It's somewhere in between being wet or dry. It's not very wet and it's not very dry. And the curves don't always look as nice as that. So all of these we see relatively similar, but if we go down, so what have we got? Oh, I've put it up here. That's the optimum moisture content. So that's the moisture content you can achieve that bulk density at. So these are gravimetric, so mass per mass. So 27%, what have I got there? 25% and 21%. What I did was then plot that's the soil moisture profile right before it was trafficked underneath there. So they're on exactly the same scale for each of the farms. And what you can see, somewhere in that top 40 centimetres, you were close to that optimum moisture content, except for Oscott, which were close to it at the surface, but a little too wet immediately underneath, and they just had rain before we got down there. 0 to 30 centimetres, by the way. I'll step back a bit. Why did they develop the proctor test? The proctor test is actually a civil engineering test to allow them to determine this value at the point here, so they make sure the soil was wet enough that when they were running their sheep's foot roller over it, that they could achieve maximum compaction. So the force that's applied in this test is an equivalent force to a sheep's foot roller, which is why Jamie let us run a sheep's foot roller through his paddock. So we've done this test at his place, and we'll look at what the field says as well to try and cross-validate the test. But for these soils here, we see what we'd expect to see. We're seeing compaction, and this is post, and that's pre, in terms of traffic. Now these are a little bit different so don't expect them to look like this. They're moistures, okay? But this one over here, we didn't see too much of a change at the surface. It's a little bit to do with it being dry, but it's more to do with it being that it was highly variable prior to traffic. But what we do see is an increase down the profile, and again increases here and here. What I find really interesting is that the resulting bulk density is greater than the measured maximum dry density. So that point on top of the curve, these points here, the actual bulk densities that we measured were greater than that. Now that's not impossible. That simply means that these machines are transferring more force into that soil than a sheep's foot roller, which is being used to prepare roads. So I guess the message from here is that when you don't have any contracting to do, you might be able to go down to one of the road traffic guys and work on the roads, maybe make your money back that way. But seriously, that's something that should be concerning. The road traffic plant designed for compacting roads for solid foundations is having less of an effect than one of these machines in your field. And those moisture contents, they aren't all that high. So when people say it's all right, we've had a dry pick, which is what we were told at Warren. Oh, it's relatively dry, not much of an issue. But we see this, and this is the second year's worth of compaction. Sorry, that was the other issue, why that would probably be relatively compacted there. Second year's worth of compaction on this soil. So the effect is compounding in that case, but it's also occurring where the soil moisture isn't all that wet. So it's not wet in terms of what many of us think is wet. It doesn't need to be sopping wet. That's the message. Anyway, that's impact. So as far as energy implications go, we wanted to directly compare the JD 7760 to the previous basket system, but that proved quite hard. So Tony Taylor and myself and a couple of the others of us got together and we thought, well, how can we do this? And we posed 3 tillage regimes over the same paddock and replicated that down the paddock. So we had low, medium and high tillage. The low tillage was pupae busting only. And I've got a better description of this in a table that's coming up. But then we used what they thought was the conventionally or the basket required tillage system, and then what they perceived was needed now. So this is out at John Norman's place. As I said, it was replicated, and unfortunately we have it only for a single season. So we've got the pre-data, which was done in the first year, then we've got the follow-up data, but unfortunately no cotton was grown, and it was then cultivated offline. So we can't follow it up there any further. So 1 year's worth of data, keep that in mind. This is our yield, and you can see high, medium, low there again. That's just giving you some idea of the yield in those treatments. If you look at the low, it's probably the only one you can see visually. There is a reduction in yield. We might expect that. Here's the actual numbers. So as I said, there's a little bit more detail for the low treatment and medium and the high there. As far as seed and cotton, yes, there were some significant effects. So it reduced as your tillage reduced. But if we have a look at the yield, what we've done is worked out the yield in terms of your total bale weight, and you can see that there is an increase. And the CRDC guys even questioned me on this. I said it's not a significant increase. That's because there's a bit of variability. But you can see there is an increase from the medium to the high. But when I say it's not significant in terms of A, the variability, but B, the amount of money that you're spending to do that. So if we look at the productivity, and we've calculated this on kilograms of cotton per litre of fuel, tillage only, per hectare. So we've assumed everything else in the system's equal, which may or may not be fair, but that's how it was treated agronomically. So you would probably adjust these other inputs as well. That's why we haven't included those in the data there. But as you can see, our pupae bust only, so light tillage, actually gave us the better return. And when you work that out across a farm, that's a very significant difference. Indeed, if we go down and have a look at the medium and the high, we can see that there are some big drops as we go to medium, then as we go to high. This says to me, one, probably don't need to be doing what they perceive, so the double pass and that deep. And the initial thinking is that, well, maybe I can get down below my compaction. But if we just jump back a couple of slides, we see that compaction effects are occurring down to 80 centimetres. And I'll show you some more data about that very, very shortly. Yep, no worries. So that also says to me that perhaps we weren't even optimised in the previous system. So there's a big opportunity, I think, in optimising energy in field, but it also needs to be done in conjunction with the system. If we think back to that impact, that's a significant impact. So here we looked at the CTF versus the standard configuration. Auscod have been using a 3 metre track CTF JD 7760, which is picking 1.5 metre rows, only picking 4 rows. If you calculate that out, that's a 12 metre front. That allowed them, sorry, not 12 metres, it's a 6 metre front, allowed them to keep onto their 12 metre planting and cultivation system. So, as you can see, the 1 metre space in the cotton's a little shorter, and obviously it's closer because it's only at 1 metre. We followed that through. This here is our comb penetration across the field for the two systems. And the point I want to make out of this, measures soil strength, and soil moisture is very important about this. I haven't pulled that out or calibrated it for moisture. But if you look at this 27.5 and 32.5, that on average, and this isn't all the data, they were the plough pans forming in terms of the changes in strength. And as you can see there, on average, an extra 250 metres cube per hectare compacted under the standard. So think of that as a reduction of 250 metres cube per hectare of your moisture bucket for growing cotton. That can be quite a significant thing. If we look at the density, so the dual wheel machine has this effect. So it's increasing the bulk density, significant down to that depth there. Not significant here, but we saw a reduction in variability. So it wasn't significant, but we'd made the paddock less variable. So if we mapped it out naturally and these were an error bar, naturally we've got some error bar like this, and then we run the machine over and it goes down to like this. It was 1/10 of the variability. And the only thing we'd done was put the big heavy thing over it. So that says to me that even though it's not a significant effect at 80 centimetres, we are having an effect. So over time, there is going to be a build-up of plough pan underneath these machines. So the further the wheels are apart, the better that is. If we look at the CTF machine, not significantly different from the two machines, but again significantly different from the other wheels. We expect that. What's interesting is that in the first year, the gross margin was equal, but the CTF system wasn't producing as high a yield as the standard, which might be logical considering that you've got less cotton per hectare, for example. But in this next year, we find that that we actually end up with more production. So where does that leave us? We know that the standard JD7 and 760 increases soil compaction, and it's having an effect that's pretty extreme when we put it in the terms of civil engineering road construction equipment. So how do we manage that? We can't cultivate underneath it. We can control where we put our wheels, but that's not cheap. And that speaks to that last point there. The other major point is that we probably need to revisit energy optimisation and looking at the two systems side by side and changing our energy or our cultivation strategy at the same time makes complete sense. So changing to CTF is expensive, of course, we know that. One of the ideas that myself and Jamie Grant sat down and talked through was that if you went to picking 5 rows, which doesn't actually change, doesn't sound good because you're only using 5-year heads, but you're getting through the paddock at relatively the same speed. So your in-field efficiency isn't really changed. But what it does allow you to do is keep your metre spacing for the time being, go to 3 metres, not have to change your tractors because they can be picking in between there and only planting cultivating on 10, or you can stretch your tractor out as well and be on 15. That's an option. It's a stepwise way to move towards CTF. What do we need to do in the future? Well, the next thing is a systems approach is needed. Long-term demonstration sites need to be set up. And that's what we couldn't look at was water use efficiency or the nitrogen use efficiency in terms of the two different plant row systems. So that needs to be done over a longer period of time. It also needs to be done with CTF and non-CTF side by side and understanding cultivation. So it's a big effort. It's not one research group doing it, but it's something that the industry should be considering. And that alone is insufficient, as we heard from Mick and Brett, and I'm sure plenty of us have discussed before. Predictive capability would be fantastic. SoilFlex, which is one of the models we've been using, will allow us, we're validating at the moment, and it should allow us to say, my soil's this wet. I can fingerprint the machine doesn't change too much. So we know what the force going is, and it'll give you an idea of what the risk factor is in terms of compaction versus cultivation. And then if you integrate that back into a number of other systems, which is not going to happen tomorrow but down the track, what you've got is something that's pretty powerful. So intelligent use of information power in big data or large data. I do agree with Brett, big data is probably not the right term for agriculture. All right, that's me.